Welcome, YouTubers, to another episode in my Grammar Hero series. In today's video, I'm going to be working out the problems from the 11th full-length practice test on my website. More specifically, I'm going to be working out the problems from the mathematics knowledge subtest of that practice test. In case this is your first time finding my YouTube channel, I quickly want to mention that I have a small website called ASVABapp.com. There you can take 11 practice tests, including this one. All the resources on my website are completely free. You don't have to register or sign up for anything. All you have to do is go there and start taking the practice test. If for some reason you don't want to go to my website to take this practice test, you're more than welcome to work out these problems alongside me here on YouTube. In that case, I'd recommend that you pause the video after I read each question, attempt to work out the question on your own, and then resume playing the video to check your solution. As a reminder, you're not permitted to use a calculator or a reference sheet on the ASVAB, so regardless of where you take this practice test, try not to use any of those resources. Finally, I want to say that in the description of this video, I'm going to include timestamps, and those timestamps are going to be associated with each question. Next to the timestamp is going to be the name of the topic that the question's testing, as well as the link to video in which I discuss that topic in greater detail. So if at any point you feel as if you're getting stuck on one of these questions, just look in the description of this video, and there you'll find those links to additional resources. So all that being said, let's go ahead and get started with today's video. Number 1 says, which of the following is the smallest prime number greater than 200? All right, so on my YouTube channel, I have a video that would help you answer this question almost instantly. And that video is called Prime Numbers and Divisibility Rules. In that video, I covered two general ideas. One, I define what a prime number is. And two, I show you how you can use divisibility rules to quickly determine if a number is prime or not. As far as prime numbers go, you should know that a number is considered prime if it's only divisible by 1 in itself. So for example, we would say the number 5 is prime because it's only divisible by 1 and 5, that is 1 in itself. We would say the number 6 is not prime because in addition to being divisible by 1 in itself, it's also divisible by 2 and 3. All right, so therefore it wouldn't be prime. So with that definition in mind, let's talk about divisibility rules and how we can use them to check if a bigger number is prime or not. Well, we're going to take divisibility rules for 2, 3, and 5, and we're going to apply them to all of our answer choices because if a number is divisible by 2, 3, or 5, then it can't be prime. All right? So as far as the divisibility rule for 2 goes, what you want to do is you want to look at the last digit in a number. So the last digit in 201 is right here. It's 1. And if the last digit in a number is even, then the number is going to be divisible by 2. 1 in this case is odd. So I know 201 is not divisible by 2. 5 is the last digit in 205. Since it's odd, I know 205 is not divisible by 2. 1 right here in 211 is odd, so I know 211 is not divisible by 2. But if we look at the last answer choice, notably 214, we can see its last digit is 4. 4 is an even number, therefore I know 214 is going to be divisible by 2. And since 214 is divisible by something other than 1 in itself, it can't be prime. All right, so we use the divisibility rule for 2 to eliminate 214 as an answer choice. All right, let's move on to the divisibility rule for 3. The divisibility rule for 3 says this: if the sum of the digits in a number is divisible by 3, then the number itself is divisible by 3. So let's look at 201. Let's sum its digits. Again, we're looking at the number 201. Let's sum its digits. So let's do 2 plus 0 plus 1. 2 plus 0 plus 1 is 3. Is 3 divisible by 3? It is. 3 divided by 3 is 1. So since the sum of the digits in 201 is divisible by 3, then I know 201 is also divisible by 3. And since 201 is divisible by something other than 1 in itself, it can't be prime. And let's check B and C real quick. Again, we're just summing the digits in a number, so we're looking at the number 205. The sum of its digits is 2 plus 0 plus 5. 2 plus 0 plus 5 is 7. Is 7 divisible by 3? It's not. Therefore, I know 205 is not divisible by 3. And let's take a look at 211 now. We're going to sum its digits. 2 plus 1 plus 1. 2 plus 1 is 3 plus 1 is 4. Is 4 divisible by 3? It's not. So I know 211 is not divisible by 3. All right. So we're down to 2 answer choices at this point. And by applying the divisibility rule for 5, we'll probably figure out which of these is correct. All right. The divisibility rule for 5 says this. If the last digit in a number is 0 or 5, then the number itself is divisible by 5. So for 205, we're looking at its last digit, notably 5. And since that is a 5, I know 205 is going to be divisible by 5. And since 205 is divisible by something other than 1 in itself, it can't be prime. And just like that, we eliminated all the incorrect answer choices. So I know the correct answer choice to number 1 is C, 211. All right, so let me just stress this. I know these divisibility rules so well that I can apply them mentally and just look at the numbers and determine which one's prime. That's the point you want to get to with divisibility rules and prime numbers. Again, I would look at 214, say it's divisible by 2, cross it out. I'd look at 205, say it's divisible by 5, cross it out. I'd sum the digits in 201, say it's divisible by 3, and cross it out. And then I would have 211 left, and I would know that's the correct answer choice. So I know I'm working this out to show you the logic behind what I'm doing. In reality, you should get to the point where you can solve these mentally by applying divisibility rules, because the divisibility rules, as you just saw, are very easy to use. All right, so that's the first one. Answer was C. Number 2 says, if 40% is equal to the fraction x over 30, then what is the value of x? So for this problem, the goal is to rewrite this statement as an algebraic expression that you can then solve for x. And as it happens, this one's not too difficult to do. In this case, we're going to start by converting 40% to be in decimal form. And the decimal form of 40% is 0.4. According to the problem, 40% or 0.4 is equal to the fraction x over 30. So just like that, I took this statement and rewrote it as an algebraic expression. I'm going to go ahead and copy that down right here so we can have more room to work with. Again, that's 0.4 or 40% equals x over 30. And at this point, we're just solving for x. So the first thing we want to do is clear this 30 from the denominator. So we're going to multiply both sides by 30. This will cross out here, leaving you with x on this side. And as you can see, x is equal to 30 times 0.4. Well, I'm actually going to work that off to the side. Again, that's 30 times 0.4. And as you can see, we're multiplying a whole number, notably 30, by a decimal, notably 0.4. So what you want to do is shift the decimal in 0.4 one time to the right, such that this becomes 30 times 4 with no decimal place. And once we work this out, we'll take the decimal that we shifted one place to the right and shift it one place to the left over here. 4 times 0 is 0. 3 times 4 is 12. Shift our decimal back in one place to the left. So we can see x is going to be 12. And in math, it's customary to write the variable for which you solved on the left. So this says x equals 12, which is answer choice D in this case. All right, so that's that one. Again, you do have to get pretty proficient at converting statements into algebraic expressions that you can then solve. And this was a good example of one of those problems. Number 3 says, what does the expression 5 factorial equal? Well, in case you haven't taken a class on statistics, I just want to mention that factorials are represented with the exclamation symbol. So 5 factorial is the same as this, 5 exclamation points. And what a factorial says to do is take that number, so in this case we're going to take 5, and multiply it by every number less than 5 until you get to 1. So this will be 5 times 4 times 3 times 2 times 1. And all you have to do now is work this out. Again, 5 times 4 is 20. 20 times 3 is 60. 60 times 2 is 120. 120 times 1 is 120. So 5 factorial is 120, which we can see as answer choice B in this case. All right, so that's that one. Pretty easy problem. Number 4 says a woman has $500 in a bank account. Every week she writes out a check for $50. If she doesn't make any new deposits, how much money will be in her bank account X number of weeks from now? All right, so once again, we have to take a statement and convert it into an algebraic expression. And in this case, it's actually pretty easy to do. First, we know that she has $500 in a bank account. So let's just go ahead and write out $500. And in addition, we're told that every week she writes out a check for $50. That means every week her account's being reduced by the amount of $50. So that's going to be subtract 50. And if we want to know how much money's in the bank account X number of weeks from now, that's going to be 500 minus 50 times X. So the correct answer to this one is B, 500 minus 50X. All right, so that's that one. Pretty easy one. Number 5 says subtract negative 3x squared minus 5x plus 1 from 8x squared minus 2x minus 9. In other words, we're subtracting two polynomials. And the key to this one is to set it up correctly. And this is what that looks like. Again, from 8x squared minus 2x minus 9, we're subtracting the polynomial negative 3x squared minus 5x plus 1. All right, if you didn't set this one up this way, chances are you didn't get the correct answer. And here's why. When you subtract negative 3x squared minus 5x plus 1 from 8x squared minus 2x minus 9, you actually have to take this subtraction sign, which is technically a negative, and you have to distribute it here, here, and here. That is, you have to distribute it to all the terms in the second polynomial. If you don't do that, you're going to get this one wrong. All right, so let's go ahead and distribute that negative. Again, we're not going to touch this 8x squared minus 2x minus 9 right now. We're just simply distributing this negative. A negative times a negative is a positive. So negative times negative 3x squared is positive 3x squared. A negative times negative 5x is going to be positive 5x. And negative times positive is a negative. So that's minus 1. All right. So now that we've distributed that negative, what we want to do is simplify this expression by combining like terms. Again, like terms have the same letter variable raised to the same power. So for example, the letter variable in 8x squared is x, and it's raised to the second power. If we look through this expression, we can see that the only other term with an x variable raised to the second power is right here in 3x squared. So those are like terms, and we can combine them. 8x squared plus 3x squared, that's 8, 9, 10, 11x squared. And typically, once I combine like terms, I like to cross them out. All right, moving on, we have negative 2x. Technically, this is raised to the first power, but it's not expressed. So if we're looking for its corresponding like term, we can see that's right here. So we can combine negative 2x and positive 5x. 5x minus 2x is simply plus 3x. And then finally, we have negative 9 and negative 1. Negative 9 minus 1 is negative 10. All right, so the answer to this one is 11x squared plus 3x minus 10, which we can see is answer choice D in this case. All right, so again, if you're ever asked to subtract polynomials on the ASVAB, you need to set the second one in parentheses and distribute that negative. A lot of people would get this wrong because they would do 8x squared minus 3x squared, and they would say that's 5x squared. Well, technically you would have 8x squared minus negative 3x squared. That's a double negative, so that turns positive. So regardless of how you set this up, you're still working with those negatives. All right, so that's that one. Number 6 says evaluate the expression using the given values. Y to the third plus yz plus z plus y when y equals negative 2 and z equals 6. All right, so to start this one, I'm going to copy down the expression y to the third plus y times z plus z plus y. And I'm also going to note that the problem told us to let y equal negative 2 and z equals 6. All right, so to start, I'm going to plug in negative 2 wherever I see y in this expression and 6 wherever I see z. So let's go ahead and work on doing that. So y to the third is the same as negative 2 to the third plus, again, y is negative 2, so this is negative 2 times z is 6 plus z is 6, so this is plus 6. And then plus, again, y is negative 2, so this is plus negative 2. All right, so now that we've done that, we have this expression with nothing but real values. And if you need help deciding how to simplify this, you're always going to follow the order of operations. And I remember the order of operations with the acronym PEMDAS. That is to say, you're going to do what's in parentheses first, exponents next, multiplication and division as they appear in the expression from left to right. That is to say, you treat those as equals, and then addition and subtraction as they appear from left to right in the expression. If we look through our expression, we can see that there's nothing really in parentheses to work out, so we're going to cross that out. That said, if we look through our expression, we can see that we have an exponent, notably negative 2 to the third. So we're going to have to take care of that before we can move on to anything else. And I'm going to write this off to the side. Again, we have negative 2 to the third. That's the same as negative 2 times negative 2 times negative 2. And you can either work this out like this. You should know that a negative raised to the odd power is going to be negative, or you can actually just work this out. Negative 2 times negative 2, a negative times a negative is going to be a positive, so negative 2 times negative 2 is going to be positive 4. And then 4 times negative 2, a positive times a negative is going to be a negative. 4 times negative 2 is negative 8. So negative 2 to the third is going to be negative 8. And this is plus negative 2 times 6 plus 6 plus negative 2. All right, so we took care of our exponent. If we look through our expression, you can see we have addition, multiplication, addition, and addition. So we're going to have to take care of that multiplication before we can move on to our addition and subtraction. So let's just go ahead and work that out. This becomes, and let me not write a sign just yet, negative 2 times positive 6. A negative times a positive is a negative, so negative 2 times positive 6 is going to be negative 12. And then this, I'm going to drop the parentheses here, so this is going to be plus 6. And then plus minus is just minus. So plus negative 2 is the same thing as just minus 2. All right, so we took care of our multiplication. There's no division, and now we just have addition and subtraction. Again, as I mentioned, you work those out from left to right. So we're going to do 8 minus 12 first. 8 minus 12 is negative 20. Again, that's plus 6 minus 2. Again, since we have just addition and subtraction, we're working from left to right. Negative 20 plus 6 is negative 14, and then that's minus 2. And then we just have one operation left, notably negative 14 minus 2, which is negative 16. So the answer to this one is C, negative 16. You will have to evaluate expressions for given values on the ASVAB, and you will have to make use of the order of operations. So make sure you can do both those things for the test. All right, but that's that one. Number 7 says solve the expression for x. We have 8x minus 2 minus 5x equals 8. So whenever you're asked to solve for a letter variable, your goal is to ultimately get that letter variable by itself. So in this case, we're ultimately going to get x equal to something by itself. In other words, we're going to be rearranging the values in this expression until we get to this point. So not surprisingly, I'm going to start by copying this expression down. Again, the expression is 8x minus 2 minus 5x equals 8. Right away, you should recognize that 8x and 5x are like terms, so you can combine them. 8x minus 5x is going to be 3x, so this becomes 3x minus 2 equals 8. Now we can add 2 to both sides. This will cross out here, leaving you with 3x. As we can see, 3x is equal to 8 plus 2, which is 10. Now to solve for x, we can divide both sides by 3, since this will cross out here, leaving you with just x on this side. And as we can see, x is equal to 10 over 3. All right, unfortunately, that's not one of our answer choices, so there must be something special about this 10 over 3 that will allow us to convert it to one of these answer choices. And as it happens, this 10 over 3 is called an improper fraction. An improper fraction is a fraction in which the numerator is bigger than the denominator. Clearly 10, the numerator, is bigger than 3, the denominator. And in light of that, we can convert this improper fraction into a mixed number pretty easily. And the way you do that is like this. Again, most people would read this as a fraction as 10 over 3, but when you're making that conversion, you would actually read this as long division, notably as 10 divided by 3. And in long division, that looks like this. 10 divided by 3. And if we were doing this long division, we would start by asking ourselves, how many times does 3 go into 1 without going over? It doesn't. How many times does 3 go into 10 without going over? Well, that's going to be 3 times, given that 3 times 3 is 9. 10 minus 9 is 1. And at this point, we have enough to convert this improper fraction into a mixed number. Again, this 3 is going to be our whole value. This remainder of 1 is going to be our numerator. And this 3 is going to be our denominator. So the answer to this one is C, x equals 3 1/3. All right, pretty easy problem in terms of the algebra. That said, you had to recognize you had an improper fraction here, which means you could rewrite it as a mixed number. And I believe that does happen occasionally on the ASVAB. You'll work something out. You'll be thinking about whether you did it wrong or you can convert the answer choice into something else. Chances are, in those cases, you can always convert your answer to be something else. In many cases, your answer will be given as a fraction, and you'll have to convert it to a decimal and vice versa. So just be mindful of that as you take the test. But that's that one. Number 8 says, what is 20 degrees Celsius in terms of Fahrenheit? Use F equals 9 over 5 C plus 32. All right, let me say this. On the ASVAB, you may see a question in which you have to convert from Celsius to Fahrenheit or from Fahrenheit to Celsius. Regardless of which of those questions you see, you're not going to have to memorize those formulas. Instead, those formulas are going to be given to you, as it was in this case. So in light of that, let's go ahead and get started with this one. Again, we're working with the formula F equals 9 over 5 C plus 32. Again, according to the problem, we know C is 20. So I'm going to go ahead and plug in 20 for C. This becomes F equals 9 over 5 times 20 plus 32. And a lot of people would hit a roadblock in this question right here. 9 over 5 times 20. For some reason, people struggle with fractions a little bit, but as you'll see in just a second, this is actually very easy to work with. We have 9 over 5 times 20. That is to say, we're multiplying the fraction 9 over 5 by a whole number 20. What you want to do is rewrite 20 as a fraction by placing it over 1. And then at this point, you want to try to reduce this as much as possible because it's going to save you a lot of work. You can reduce this by saying 5 goes into 5 one time, 5 goes into 20 4 times. So as you can see, this is 9 over 1 times 4 over 1. Well, 9 divided by 1 is just 9, and 4 divided by 1 is just 4. 9 times 4 is 36. Okay, so this becomes F equals 36 plus 32. And you should be able to do that in your head. 6 plus 2 is 8. 3 plus 3 is 6. So in this case, 20 degrees Celsius is 68 degrees Fahrenheit. And that's answer choice D. All right, so that's that one. Number 9 says the perimeter of a rectangle is 38 inches. If the length of the rectangle is 3 inches more than its width, then what is the width of the rectangle? For problems involving basic geometry, I always like to make a sketch to help guide my work. And in this case, we're working with a rectangle. So let's quickly make one of those. And we should know some properties of rectangles, notably that this side is equal to this side, and this length is equal to this length. Well, according to this problem, our rectangle has a perimeter of 38 inches. So in other words, P, our perimeter, is 38. And we know its length is 3 more inches than its width. Both of those, as it happens, are unknown values. And in math, you typically represent unknown values with letter variables. So I'm going to call its width x. And if this width's x, that means this width over here is also x. And again, according to the problem, the length is 3 inches more than the width. So that means that this length here is going to be x plus 3. And this length is the same as this one. So if this one's x plus 3, then this one's also x plus 3. All right. Well, how are we going to use this information about its perimeter and all these values to find its width? Well, we should know that to find the perimeter of any quadrilateral, including a rectangle, you simply add up all of its sides. So the perimeter of this rectangle here is going to be x plus 3 plus x plus x plus 3. We just added up all of its sides starting here to here. All right. And what's more, we know P is 38. So I'm going to replace this P here with 38. So this becomes 38 equals x plus 3 plus x plus x plus 3. Let's go ahead and combine like terms now. We have x, 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 and x. That is, we have 4 x's, and then we have 3 and 3, which is 6. All right, so it should be obvious at this point that if we solve for x, we'll figure out what the width of this rectangle is, since we can see that the width of this rectangle is just x. All right, so first things first, let's subtract 6 from both sides. This crosses out here, leaving you with just 4x on this side. 38 minus 6 is 32. Now we're going to divide both sides by 4. This will cross out here, and let me move down a little bit. This leaves you with just x on this side, and 32 divided by 4 is 8, so x in this case is 8. So we know the width of this rectangle is going to be b 8 inches. Again, you can see x is the width, and we found x to be 8. All right, so that's that one. Again, you do have to know how to find perimeter of quadrilaterals for the ASVAB. In addition, you also have to know some basic properties about them in order to solve these types of problems. But that's that one. All right, number 10 says, write the equation of the line that passes through the point -2, 6 and has a slope of 3. All right, so writing equations of lines is a topic that sometimes shows up on the ASVAB. And in light of that, I have a video called Writing Equations of Lines on my YouTube channel. And in addition, I devoted a big part of my reference sheet to telling you how to write equations of lines. In this case, we were given 1 point on the line as well as the slope of the line. So what that tells us to do is this. I'm going to write down that point. That's -2, 6. And I'm going to label it like this. This -2 is an x value, so I'm going to call it x1. And this 6 is a y value, so I'm going to call it y1. And we know the slope is 3. Well, when you're working with equations of lines, slope is always going to be associated with the letter variable m. And since the slope is 3, we're going to say m is 3. All right, so with those two things identified, all we have to do is plug those values into the point-slope equation and solve for y. And the point-slope equation is this: y minus y1 equals m times x minus x1. And as it happens, we know what all those things are. Y1 is right here, it's 6. M is right here, it's 3. And x1 is right here, it's -2. So let's plug those in and simplify accordingly. This becomes y minus y1, which is 6, equals m. M is 3 times x minus x1. That's -2. All right, so now that we've done that, we have to address this double negative. Minus minus always becomes plus, so this is x plus 2. And now we got to take this 3 and distribute it to this x, as well as to this 2. So this becomes y minus 6 equals 3 times x, which is 3x, plus 3 times 2, which is 6. Let's add 6 to both sides now. This crosses out, leaving you with y equals 3x. 6 plus 6 is 12. All right, so that's our equation of this line, y equals 3x plus 12. And we can see that that is answer choice A in this case. All right, so that's that one. Nothing too difficult there. All right, number 11 says, what is the product of a minus 5 and a plus 3? Product means to multiply, so we're going to be multiplying these two polynomials together like this. A minus 5 and a plus 3. And in this case, we're going to have to follow the distributive property, which says take this first term, which is a, and multiply it by both terms in the second polynomial. And then take the second term, -5, and then multiply it by both terms in the second polynomial. All right, so that's all we really have to do. As we can see, the first thing we're going to do is a times a, which is a squared. Then we're going to do a times 3, which is 3a. Then we're going to do -5 times a, which is -5a. Then we're going to do -5 times +3, which is -15. And the only other step we have to do is combine like terms. There is no like term for a squared, but that said, 3a and -5a are like terms. -5a plus 3a is -2a, and then this is just -15. All right, so the answer to this one is a squared minus 2a minus 15, which we can see is answer choice C in this case. All right, so that's that one. All right, number 12 says find the product of the reciprocals of 1/2, 4, and -2 1/2. All right, so for this problem, we're working with the numbers 1/2, 4, and -2 and 1/2. And before we can find the products, we actually have to find the reciprocals of each of these numbers. And as it happens, that's pretty easy to do. To find the reciprocal, you just exchange your denominator and numerator. That is, you flip-flop them. So the reciprocal of 1/2 is 2 over 1. And I'm just going to circle that so I know that that is the reciprocal. 4 is a little bit more difficult insofar as you have to realize that you can write 4 as a fraction by placing it over 1. And then its reciprocal is just 1 over 4. Again, we just exchange the numerator and denominator. And then the mixed number, negative 2 and 1/2, is a little bit more difficult because now we have to take this mixed number and convert it into an improper fraction. And we're going to do that like this. Again, it's going to be negative. 2 times 2 is 4 plus 1 is 5. So this improper fraction is going to be negative 5 over 2. And to find its reciprocal, again, we just flip-flop our numerator and denominator. So it's negative 2 over 5. All right, so now that we have all of our reciprocals, we just have to find the product of them, which means we're going to multiply them all together like this. We're going to have 2 over 1 times 1 over 4 times negative 2 over 5. And when you multiply fractions, you just multiply straight across. So this becomes this, 2 times 1 times negative 2 over 1 times 4 times 5. That's actually pretty easy to do. 2 times 1 is 2. 2 times negative 2 is going to be negative 4. And then we have 1 times 4, which is 4. 4 times 5 is 20. And as it happens, we don't see this as an answer choice, which means there must be something we can do to negative 4 over 20 to get it to match one of our answer choices. And in this case, it should be pretty obvious that we can reduce this fraction by dividing the numerator and denominator by a common factor of 4. 4 divided by 4 is 1, so this is negative 1. And 20 divided by 4 is 5. So the product of the reciprocals of 1/2, 4, and negative 2 and 1/2 is negative 1/5, which is answer choice B in this case. All right, so that's that one. Number 13 says solve for z. 3z minus 5 equals negative 2z minus 25 plus 5z. So as I've mentioned in this video already, when you're solving for a letter variable, you always want to try to get that letter variable by itself. So in this case, we're looking for this z equal to something by itself. Now that we recognize that, we can go ahead and copy down our expression. We have 3z minus 5 equals negative 2z minus 25 plus 5z. All right, so again, we're trying to solve for z. The first thing you should realize is that on the right-hand side of this equal sign, you have like terms in negative 2z and 5z. So we can combine those. 5z minus 2z is just going to be 3z. So this becomes 3z minus 25 equals 3z minus 5. All right, let's move this 5 over here via addition. This crosses out here, leaving you with just 3z on this side equals 3z. Negative 25 plus 5 is going to be negative 20. And finally, let's move this z to the other side via subtraction. This crosses out here, leaving you with negative 20 on this side. 3z minus 3z is 0. And as you can see, we have a bit of a contradiction here. We have a statement that says 0 equals negative 20. Well, that's an untrue mathematical statement, which means there's no value of z that you can plug in that would ever make this equation work. And in light of that, we would say for this one, there is no solution. All right, so that's that one. Number 14 says factor the following expression. We have negative 6x squared minus x plus 2. All right, so you may have noticed that in almost all of my practice tests, I have questions involving factoring. And as it happens, those questions range from being very easy to being very difficult. Well, as it happens, number 14 is actually pretty difficult. So let me try to walk you through this one as best I can. First, I want to point this out. We're factoring a quadratic trinomial that's in standard form. Standard form is this: ax squared plus bx plus c. We can see that a corresponds to -6. There's an imaginary -1 in front of this x, and c in this case is 2. That's going to be important to understand in just a few minutes here. All right, so let's go ahead and copy down this expression. We have -6x squared minus x plus 2. Whenever you have a negative in front of an expression like this, you want to go ahead and factor it out. So we're going to factor out a -1, which will make this 6x squared plus x minus 2. All right, so we should see that all the answer choices that begin with something other than -1 are not going to be correct. So we can eliminate B. And now all we have to do is factor this 6x squared plus x minus 2. And we're going to do that using the Australian method. The Australian method says take A and multiply it by C. So again, A is right here at 6. Multiply it by C, which is -2. So 6 times -2. 6 times -2 is -12. And then you want to find two factors of a times c that, when they're added together, equal b. Well, we should see that b in this case is +1. That's right here. So we're looking for two factors when multiplied together equal -12, but when added together equal +1. So that's going to be 4 and -3. 4 times -3 is -12. 4 minus 3 is +1. All right, so now that we have those two factors, what we want to do is go ahead and substitute this plus x with our two factors here. So I'm going to do it like this: minus 3x, I got that 3x from over here, minus 3, plus 4x minus 2. Okay, so I basically took that x, I used the Australian method to identify two factors that will work in this case, and I'll replace that x with both of those factors. All right, and now I'm going to factor this expression 6x squared minus 3x plus 4x minus 2 via grouping. And what I'm going to do is I'm going to imagine there's a imaginary line here, and I'm just going to factor something out of this 6x squared minus 3x. Okay, and I'm going to put a big bracket here. So what can I factor from 6x squared minus 3x? Well, I can factor out a 3x, and this will become 2x minus 1. All right, and what can I factor from this 4x minus 2? Well, I can actually factor out a positive 2, and this will become 2x minus 1. All right, so the way factoring by grouping works is like this. One of the terms that's repeated is one of your answers. So we can see we have 2x minus 1 and 2x minus 1. That's going to be one of our answers. And then we're going to combine 3x plus 2 to be our other answer. So when we factor this one, it's -1 times 2x minus 1 times 3x plus 2. And we should see that that is answer choice A in this case. All right, so that's a very difficult factoring problem, just to let you know. If you can factor basic problems, you should be good to go for the ASVAB, but occasionally you'll see things that are very difficult to factor on the ASVAB, so make sure you can factor for the test. But that's that one. Number 15 says, what is the area of the shaded section in the figure below? The circles are identical and have a radius of 5 inches. In addition, they are inscribed by a rectangle. use 3.14 for pi. All right, so in this case, let's write a little expression to represent how we're going to find the area of the shaded section. All right, so the area of the shaded section in this case is simply going to be this. We're going to find the area of the rectangle, and we're going to subtract from that the area of one of these circles, which I'm going to call the area of circle 1, as well as the area of the other circle, which I'm going to call area of circle 2. All right, so how do you find the area of a rectangle? That's always length times width. And how do you find the area of a circle? Well, the area of a circle is pi r squared, and we have two identical circles here. All right, so we can actually combine these two pi r squareds to make our formula a little bit more efficient. So this will be length times width minus 2 times pi r squared, since we had two of them here. All right, so now we have to identify things. That is, we have to figure out what the length of this rectangle is, as well as what the width of this rectangle is. But that said, we already know what the radius of this circle is. Again, the radius is right here. It's 5. So let's go ahead and plug that in. This becomes length times width minus 2 pi, and radius is 5, so that's going to be 5 squared. All right. Question is, how are we going to figure out what the length as well as the width of this rectangle is? Well, if you know the definition of the radius of a circle, that should be pretty easy to do. Again, the definition of a radius of a circle is the distance from the center point of the circle to any edge of the circle. So here's the center point of this circle, and here's a radius. From here to here is a radius. Well, according to the problem, we know the radius of this circle is 5. So this distance right there is 5. And here's another radius from here to here. Again, according to the problem, the radius is 5. Well, if I add these two radiuses together, that will give me my width. 5 plus 5 is 10. So I know this rectangle has a width of 10. Again, using the definition of the radius of a circle, we can also find the length of this rectangle. Again, because from here to here is a radius, and we know that's 5. Let's say the center point of this circle is right here. From here to the edge of this circle is 5. And from this edge of the circle to the center point is 5. So the length of this rectangle is 5 plus 5 plus 5 plus 5. 5 plus 5 is 10, plus 5 is 15, plus 5 is 20. All right, so we know those values now. This becomes 20 times 10 minus 2 pi. 5 squared is 25, okay? 20 times 10 is 200. And let's work this out. What's 2 times 25? 2 times 25 is 50, so this is 200 minus 50 pi. And at this point, we can go ahead and use 3.14 for pi. So this becomes 200 minus 50 times 3.14. And I'm going to have to work that off to the side. We have 50 times 3.14. And we're multiplying a whole number by a decimal. So what we want to do is take our decimal and shift it 2 times to the right. 1, 2. We're going to take note of the fact that we shifted it 2 times to the right. And this is going to become 314 times 50. And once we work that out, we'll take our 2 decimal places and shift them back into the left. 4 times 0 is 0. 1 times 0 is 0. 3 times 0 is 0. Before we start multiplication with this 5, we have to bring in a 0 placeholder. 5 times 4 is 20. Bring down a 0, carry a 2. 5 times 1 is 5, plus 2 is 7. And then 5 times 3 is 15. This is 0 plus 157. So again, 0, 0, 7, 5, 1. Bring in our 2 decimals, 1, 2. So this becomes 200 minus 157. And I'm going to work that off to the side so as not to make any mistakes, especially since I've come all this way with this problem. We have 200 minus 157. 0 minus 7 we can't do. We're going to have to borrow from the left. We can't borrow from the left because that's a 0, so we're going to come all the way over here and borrow from this 2. This will become 1, this will become 10, this will become 9, and this will become 10. 10 minus 7 is 3, 9 minus 5 is 4, 1 minus 1 is nothing, so we can see that this is 43 inches squared. That is the area of our shaded section in this case, which is answer choice A. Again, area is always squared, volume is always cubed. All right, so that's that one. A lot of work, but nothing too difficult. Number 16 says solve the following system of equations. We have x minus 7y equals negative 11 and 5x plus 2y equals negative 18. All right, so unless you took linear algebra in college or high school, there's really only two methods you can use to solve a system of equations. You can either use the substitution method or the elimination method. And personally, I like using the elimination method. Before I discuss that method though, I just want to copy this system of equations off to the side as if it was on my own scratch paper. So this is going to be x minus 7y equals negative 11. And our second equation in this system is 5x plus 2y equals negative 18. All right, so the elimination method says this. Take one of your equations or both of your equations, multiply it by a constant such that when you add the equations together, one of the letter variables is eliminated. And it should be pretty clear that if I take this top equation and I multiply it by negative 5, when I add negative 5x to positive 5x, the letter variable x is going to be eliminated. So that's how I picked negative 5 there. But first things first, we have to take this negative 5 and distribute it here, here, and here. So that's going to become this. Negative 5 times x is negative 5x. Negative 5 times negative 7y is going to be positive 35y. And negative 5 times negative 11 is going to be positive 55. Again, a negative times a negative is a positive. And we're going to be adding that to this second equation, notably 5x plus 2y equals negative 18. All right, let's add these together. Negative 5x plus 5x is nothing, so it's eliminated. And then we have 35y plus 2y, which is going to be 37y. And then we have 55 minus 18. Again, so as not to make any mistakes, I'm going to work that off to the side. We have 55 minus 18. 5 minus 8 I can't do, so I'm going to have to borrow from this 5. This is going to become 4. This will become 15. 15 minus 8 is 7, and 4 minus 1 is 3. So this is 37y equals 37. Again, we're solving for y now, so let's divide both sides by 37. This crosses out, leaving you with y equals 37 over 37, which is just 1. All right. So based on our answer choices, we can say with a lot of confidence that B is probably correct. That said, if you're solving a system of equations on the test, once you solve for one of the letter variables, what you want to do is take that value and plug it into either of the two original equations and then solve for the other letter variable. So I'm going to take this y equals 1, and I'm going to plug it into this top equation. Again, this top equation said x minus 7y equals negative 11. Again, I now know that y is 1, so this becomes x minus 7 times 1. Again, y is 1 equals negative 11. Let's work this out. This becomes x minus 7 times 1 is just 7 equals negative 11. Let's add 7 to both sides to get x by itself. This crosses out, leaving you with x equals What's negative 11 plus 7? That's going to be negative, well, 7, 8, 9, 10, 11. That's going to be negative 4. So we know x is negative 4 and y is 1, which is in fact answer choice B. All right, so that's that one. All right, so that is it for this video. As always, I hope you found it helpful, and as usual, you're more than welcome to leave feedback in the comments section below. In order to really prepare for the ASVAB, I strongly encourage you to do two things. One, I encourage you to download a copy of my reference sheet from my website. Again, everything on my website is completely free, including my reference sheet. And apart from learning and trying to memorize the formulas in my reference sheet, I strongly encourage you to take at least 10 full-length practice tests. Doesn't matter if they're on my website or someone else's website, but I will say this. I devote a lot of effort to writing questions that cover topics that frequently show up on the actual ASVAB. So in other words, if you work your way through my 11 full-length practice tests on my website, you should have no problem passing the ASVAB. And in light of that, you should really not give your money to any of these paid tutors or boot camps. If you want to support my channel, please consider subscribing to it. But on that note, I'm going to go ahead and catch you loose.